4?
Ah.
Yeah. Circle the correct statements.
Which number?
Number 4. Okay? So number 4 on the test.
Jump around throughout this whole test.
We've been hopscotching, but I thought we'd go back and do that multiple choice. Circle the correct statements. Okay, the first statement is the activated complex must include all of the molecules in the rate law for the elementary process.
True.
That's true. That's absolutely true. Because that is actually one of the fundamental assumptions of kinetics. Okay. Now, B. The rate law for an SN1 mechanism is 0th order in concentration of nucleophile.
True.
Again, that is true. Because actually you could look at part A for that. Because the nucleophile is not involved in the rate determining step. The rate determining step is the dissociation of the substrate into the leaving group dissociates away, leaving back a carbocation, which in a subsequent fast step is attacked by the nucleophile. So it is independent of the concentration of the nucleophile, and therefore 0th order. Because 0th order means anything raised to the 0th power is equal to what?
1. So the rate determining step is the dissociation of the
Substrate into leaving group and carbocation.
Cool.
Okay. Now C, which for some reason was a little bitty C, if there is an increase in charge going from reactants to activated complex in a process, then increasing the polarity of the solvent will lower the activation energy.
That's in the test already, kind of, right?
Yeah.
Okay.
Well, that is that true or false? Again, it's true.
Slightly decreased.
It will, well, increasing the polarity will actually give you a large increase. It depends. Well, no. Wait a minute.
What?
Yeah, that would be the case
Speed of loading.
in it'd be class 1 type of process where I have neutral nucleophile and substrate, and I'm going to increase in charge. That sort of requires that. If I have charged nucleophile, then I don't have an increase in charge. I have the charge being diffused over the activated complex. This is back to electrostriction. Okay? So that is question 4. Now, where's the next multiple choice? Oh, 7.
Second 7.
The second 7 being the one after the first 7. Circle the correct statements. Nuclear processes are driven by the production of elements with greater binding energy per nucleon.
True.
That again is true. That is why, like I said, and I should have said earlier, this is why we see the production of being an exothermic process, the nucleosynthesis going from hydrogen to all of the elements up to iron, which is going on in the sun. And when it gets to iron, beyond that, fusion is no longer exothermic because we don't have an increased binding energy per nucleon. So that's where it pretty much stops, and the sun starts to cool off. And we only have about 4 to 5 billion years before this is going to happen. So if there's anything you haven't done, you should go out and do it. Anything you want to do, you should do, because we've only got 4 or 5 billion years before it's all going to fall apart. So, extra motivation. Okay. Okay, carbon-14 decays by beta emission to produce nitrogen-14. Is that true? Again, it's true. You verify that by just writing it out and balancing it. Okay, part C. The potassium in our bodies makes us radioactive.
True.
That is true. Yes. And it is because they emit what type of particles? Beta particles. They emit electrons. And so it's not a really devastating type, but it is an ionizing type of radiation. It is going to, we need the potassium. It has to do with the abundance of the particular potassium isotope that does that. But we are, all of us, radioactive, and we die without the potassium. Now, D, and there's a typo. Because actually we're going to talk about that answer. An isotope with a half-life of 639.1 years has a decay constant of K equals 0.001 per year. Now, the problem with that is, as written, is it true? No, it's false. So if that's what you see, you answer false and you're on solid ground. The typo occurred because I wanted to write 693.1, but I had a dyslexic event while I was sitting at the keyboard.
Oh, I see.
You see why I would choose 693.1?
Yeah.
Because what's the natural log of 2?
0.693.
Yeah, and what is, okay, I'll go to the board here. For a half-life, T1/2 is equal to natural log of 2 divided by K, and therefore K is equal to natural log of 2 divided by T1/2, and that happens to be equal to 0.6931, which you can easily find without a gizmo by your knowledge of the logs of the first 5 prime numbers and the knowledge that e to the 2.303 is equal to 10. So we can find it that way. What's the log of 2? And 2 equals 10 to the 0.301. So we can easily find that the natural log of 2 is equal to 0.6931 divided by T1/2. So we can find K that way. And if we did that, we would find that that answer would be true. But because I have the typo and I permuted these two, it's false. So we're covered either way. Whatever you see on the test, go with that. Okay? Now, the last one, delta M, on the last one in 7. Delta M is less than 0 for any spontaneous nuclear process. That is true. That is analogous to for every spontaneous process, the Gibbs free energy delta G has to be less than 0. And since we're using the famous Einstein relation where delta E is equal to delta M C squared, delta M has to be less than 0. Okay, now we're on to number 11. Okay, circle the correct statements. For every process, Q is path independent. False. Because Q is not a state function. Okay. B, for every process, W is path independent. Again, false, because work is not a state function. And by the way, Q corresponds in that context to what? Heat. Yes. And the first law says delta E equals Q plus W, because we're chemists. Now, if we were engineers, it'd be Q minus W, because engineers are, well, we won't talk about engineers. If you can't say something nice, don't say it. Okay. For every process, C, delta E is path independent. That is true. Why is that true? Because it's a state function. Okay, and part D. For every state function, there exists path independence.
False.
True. Absolutely. So pretty much we beat that question to death, didn't we? Okay. E. For every equilibrium process, if K is less than 1, then the reaction favors the products? False. Because K represents, what do we call that? The mass action, or the equilibrium constant, the mass action expression. It's the ratio of products, each raised their stoichiometric coefficients, divided by reactants, each again raised their stoichiometric coefficients. So if that's less than 1, that means that there is less product than there is reactants. So it means it favors the reactants over the products. Okay. Part F. For every equilibrium process, if Q is less than K, then delta G is less than 0, and the rate of the forward reaction is greater than the rate of the reverse reaction. Boy, is that a good question. Is that true? Yes, it is, because if for every, I got to read it again. Oh, if Q is less than K, this is a Chatelier's principle, right? If Q is less than K, then the ratio of Q over K is less than 1. And the natural log of anything less than 1 is negative. And delta G is equal to RT times the natural log of Q over K. Which is a lot. I'm doing this square pictures. But Q over K. Okay? And so it has to be negative. Which means the delta G is less than 0. So that means there's a driving force for the forward reaction, which will proceed until what condition is satisfied? Till, equilibrium, which is described by what? Delta G equals 0 and Q being equal to K. So the ratio is Q over K is 1. The natural log of 1 is 0. Because R and T have to be positive. R is a constant. And T, in absolute, in Kelvin, is positive as well. So, that question is a really good question.
And it's true.
And it's true. Okay. G. For every spontaneous process with a negative change in entropy. Oh God, this is fun. The process is not spontaneous when the temperature is greater than delta H over delta S. Okay, I got to think about this one for a minute. I'm going to have to write it down to make sure. I think it sounds good, but at this point, I think about anything sounds good. Okay. Delta H, delta S. Remember this table, we wrote out that delta G, which is equal to delta H minus T delta S, and this is less than 0 when? If this is positive and this is positive, under what conditions is this going to be negative for?
I read that chart out wrong.
T is greater than H.
Yeah, it's supposed to be a T. I don't know.
For T, so this is going to be negative. If this is positive, it's going to be for T greater than delta H over delta S. Now, if this is positive and this is negative, when is this ever less than 0? Never. And if this is negative and this is positive, when is this less than 0? What temperatures? Always. And if this is negative and this is negative, Under what temperature condition?
T has to be less. That's true.
So, what word did I describe here?
It's true. Very spontaneous process is negative.
Yeah.
Entropy process is not spontaneous.
Yes, absolutely.
It can never be spontaneous.
What? For every spontaneous process, let me read it
No,
again.
it can never be, right? It's just entropy is negative.
For every spontaneous process with a negative change in entropy, the process is not spontaneous.
It can never be.
But did you tell us anything about?
I didn't tell you anything about the enthalpy.
Yeah. So that makes it kind of hard.
Oh.
Okay,
No, but you guys supposed to
so that one is
team
Pleasure.
ambiguous.
Right there.
What?
Give us a T greater than
You
helping
just gave
someone
us
else.
right there
Yeah.
the answer in the chart.
That's 2 out of
Because
3
the
right
fact
there.
that entropy is negative, it can never be positive. It can
Unless
never
delta
be
H
spontaneous. So
unless
that's not you
delta
can-
H is negative.
Oh,
Then something
okay.
exists.
Well, delta S can be negative here if my enthalpy is negative.
Oh, true. Okay.
So you see what I'm saying? It's an ambiguous question.
Ah.
I thought it sounded like a good idea when I wrote it.
Yeah.
But you guys, if you know that I'm perfectly more than capable of throwing it up. So we'll take that one as null. That's a bad question.
I love how you diagram that whole thing out.
But
You should know this because I could ask you a question that would not be bad.
Oh, wait, no, because you say when T is greater than delta H over delta S. That means it can't be the bottom.
Oh, right.
is clearly not negative.
Oh, T is greater than delta H.
You just stated.
I just said that.
Oh, you're right. So it is.
So it's never, yeah, it can never happen.
Yeah. Wow.
So does that mean it's true or false? I'm getting dinged.
It's true.
That means it's true.
It's not spontaneous. It's not spontaneous.
It's not spontaneous. Thank you. You guys are helping me out. I would be lost without you. Okay. Now, 12.
Yeah, it's true.
Yeah, so it's true.
because it could have been.
It's true.
But if you didn't put that in the part, you could have been really ambiguous.
I could have written it better.
No, that's actually written really well.
Should make it more clear.
Because you have to think about both sides.
Okay.
Question is.
Number 12. Circle the correct statements. The delta E for a process is equal to the activation energy for the forward reaction minus the activation energy for the reverse reaction.
That's true.
That is true.
Is that because it equals 0?
No.
Or what?
No, it's because, let me find an eraser. Oh, you're aimed at this board, so I'll use this board. If I have a process where I have E sub A for the forward process, and I have E sub A for the reverse process, then delta E is equal to, so I'll call this E sub A forward and E sub A reverse, equals always the final E sub A R. No, what did I say in the question?
Final minus
Did I say the reverse? What did I
Forward
say?
minus
Forward, yes. Equals E sub A forward minus E sub A reverse, which is whoa. You see that?
Yep.
That's delta E.
Why are you starting to say products minus reactions in the previous?
Well, I was always, because delta is always final minus initial. But I got confused. But I wrote it, the forward minus the reverse. Yes, E sub A. And that is a true statement. So you have to actually look at the diagram here to see that. But it is true. Do you agree? Good. Okay. Now, where are we? Okay. C, I believe.
B.
No, B, being the one after A. E sub A is always, the activation energy is always positive. Absolutely true. Yeah, the barrier for every process. It can be awfully close to zero. For radical reactions, it is awfully close to zero. And they're very fast, and usually explosions occur. Okay, C. Now we're at C. At equilibrium, the rate of the forward reaction is equal to the rate of the reverse reaction. That is absolutely true. And D, is that the last one? And last but not certainly least, we need a drum roll. Okay. Thank you very much. At equilibrium, delta G is equal to 0. Is that true?
Yes.
You betcha, by golly, Jim Dandy Boy, howdy. And I would thank each and every one of you for attending this, and you've all been very helpful. I couldn't have got through this semester without you.
You're right, this is finals are.
You have learned. I have learned a great deal from you. Yes,
So I just want to make sure all the ones you next
Half if I got 60 on it.
extra credit now.
they're going to be extra credit,
That's crazy.
but don't worry about them. I want you to focus on. I don't want you to bog down and
How are you gonna grade? How are you gonna grade the extra credit?
like I grade the normal ones.
Yeah.
No, wait, because I saw that he was gonna be working.
That's what it says, but
Extra
he's
credit.
retired.
Have plenty of questions.
Extra credit is just added on.
Okay, cool.
So, good luck. It's been a pleasure, etc., etc.
Ridiculous.
See you on Tuesday. I have a question. Okay, what's
If you have